Okay, so this problem we're going to differentiate a product. If you notice, it's a product because we've got some things multiplying, right? In this case, we've got 3 factors of 5x minus 5, and then we've got 5 factors of this 3 minus x to the 4th. So this is a product rule. However, each of these factors within this product has an exponent. In this case, you have an exponent of 3, exponent of 5. So in conjunction with the product rule, we're also going to need to apply the chain rule. So let's start off with the idea that this is a product, and I'll just label it f times g. Remember, the derivative of a product is the derivative of, I'll write it in the form that I prefer, the derivative of the first factor times the second factor plus the derivative of the second factor times the first. So if we follow that form, we're going to have, let's see, the derivative of the first factor is this whole thing, right? So with the chain rule, we got to bring the 3 down. We rewrite the inside, reduce that power by 1, and then multiply by the derivative of the inside, being 5x minus 5. So the derivative of that is just a 5. So that's f prime. And then we're going to multiply by the second, g, which is just 3 minus x to the 4th, all raised to the 5th. Okay, then we're going to reverse the order here. We're going to take the derivative of the second factor now, which I call g, this piece. Bring the 5 down, 3 minus x to the 4th, reduce that power by 1, and then the derivative of the inside in this case is negative 4x cubed. And then again, we got to multiply by the first factor now, just the 5x minus 5 cubed. Okay. Now this is the test. All you really would have to do, it should take the answer. You just simply multiply the 3 times the 5, and then the negative 4 times the 5, just to condense the coefficients as best you can. Now, the question that was asked of me specifically here was how to go further from that. Because if you get this question wrong, the answer that they'll provide will be the fully simplified answer, even though it will take something a little bit less simplified. So, I would encourage you for this problem to go for the simplified answer. So let's start by doing it the bare minimum. Let's multiply the 3 and the 5 here, and then we'll also take care of this negative 4x cubed and the 5. And then we'll focus on pulling out common factors. So right now we've got 3 times 5 makes 15. And then we got negative 4x cubed times 5 is negative 20x cubed. And then we still have 3 minus x to the 4th. And we have 5x minus 5 to the 3rd. Okay, so now we'll focus on common factors, greatest common factors. And the best way to do this is just piece by piece, right? Like we'll just start with the numbers, the coefficients, 15 and 20. Well, they share a factor of 5, so we're going to pull a 5 out. Then we'll move on to this binomial factor. There's 2 terms here, and we've got 2 factors of it. So we've got 5x minus 5, 2 factors here, and then over in this term, we've got 3 factors of 5x minus 5, right, to the 3rd. So you can only pull out what's common, which is always going to be the lowest exponent. So we're going to pull out 5x minus 5 squared, 2 factors of 5x minus 5. Now for this next binomial factor here, if you notice it shows up 5 factors here, and I honestly think I'm missing something here. There's supposed to be a 4, right? I just neglected to bring this 4 down here. That was to the 4th. Okay. So in this term, we have 5 factors of the 3 minus x to the 4th, and in this term, we have 4 factors. Notice the exponent being 4. So at most, we can pull out 4 factors of the 3 minus x to the 4th. So we'll put that to the 4th power. And then we're left with what's left in each of these terms after having pulled out the greatest common factor. So we notice we pulled out a 5 from this 15. That leaves a 3. We pulled out both factors of 5x minus 5. We put the whole squared. And in this case, we pulled out 4 factors of 3 minus x to the 4th, and there was 5, so that leaves behind a 3 minus x to the 4th. Then we got a minus sign. From that minus 20, we pulled out a 5, right? So that leaves behind a 4. We did not pull out any x's, so we still got the x cubed over here. We pulled out 3 minus x to the 4th, right? We put out all 4 factors of that. And we only pulled out 2 factors, 5x minus 5 squared, and there's 3 here. Notice that's cubed, so that leaves behind 1 factor of 5x minus 5. Okay, now all that's left to do from here is to just simplify the inside, and this should be the answer that they have in MyLabs Plus, assuming you got the answer wrong and they're giving you the correct version. Although, as I said, it will take a couple different variations of this. All right, so we got 9. If we distribute that 3, minus 3x to the 4th, and then we've got a negative. This is going to be, 4 times 5 makes 20. X to the 4th, right? Because x cubed times x, that's x to the 3 plus 1, so x to the 4th. And then we've got positive 20x cubed. So if we combine like terms here, it doesn't matter what order you put it in, really. You know what? Yeah, I checked it out, and they're actually doing something a little bit sneaky with this factor here. So we'll worry about that in a second. And like I said, that little extra point is not that big of a deal, but I will show it to you because the answer they got for this problem is a little bit tricky maybe at the end as far as simplifying it. Let's see, that being said, let's write these terms here because I did take care of the distribution within this factor over here. So I've got 9, let's see, we've got, it doesn't really matter again in what order you put it in either. Maybe it makes sense to have, if you want to put it in descending order, you have a negative up front, not really a big deal. We'll call it negative 23 x to the 4th plus 20x cubed plus 9. Again, they might have a different order in the final answer of these 3 terms. Maybe they got like it's 9 minus 23x to the 4th or something. It doesn't matter. As long as the signs are the same, it really is no matter how you arrange these terms. Addition is considered a commutative operation, meaning the order that you do it doesn't matter. So if the final result has different order amongst these 3 terms, that's not an issue. Now, one thing that is weird about this problem, now this is a perfectly fine answer here. I'll take it and the homework would take it. But I notice in this form, they've actually got 125 as the coefficient. And it's a little bit sneaky because it has to do with this binomial factor. And it just so happens that because you've got a coefficient of 5 and you get this 5 here, there actually ends up being a common factor of 25. Very hard to see, I think, without, maybe having done it a few times. So let me show you. If we were to FOIL this out, right, if you do 5x minus 5, or so 5x minus 5 times 5x minus 5, you can write it side by side and do it, FOIL it out, or you can just use a standard form. You're going to square the first term, you get 25x squared. We multiply these terms together and then double. So we're going to have, let's see, 5 times negative 5 is negative 25 doubled is negative 50x. And then we square the last term. So this is another way to write 5x minus 5 squared. Now what's interesting to notice here is there's 25 that's common. So if you pull out a 25 times the 5 that's already there, you're going to be left with x squared minus 2x plus 1, right? Which is still not fully factored at this point. We got 5 times 25 is 125. And then this can be reverse FOILed, or maybe you recognize this as what's called a perfect square trinomial, right? Because it breaks down as x minus 1 times x minus 1, or we can write it as x minus 1 squared, right? If you were to factor this, sometimes it's helpful to expand. If you're not too familiar with factoring, you get x squared, you get minus x, you get another minus x, and then you get a plus 1. So, this just proves this is actually how this trinomial will reduce as a perfect square trinomial. So, again, this problem is a little sneaky because this is actually how they have it written, right? They reduce this whole front factor here, this whole 5 times the quantity 5x minus 5 squared to this 125x minus 1 squared. So if you see it that way, that's why it looks that way. So the final result, if I was to put it all together, I'd write it in blue. Why not? Just to color differentiate it here. We've got 125. It was x minus 1 squared times the 3 minus x to the 4th. And a whole quantity to the 4th. I'm already messing up. And then, of course, all this stuff as well, right? You just tie that right there. Okay, so that was a good question to ask. Again, going this extra result here is not such a big deal. It's just practicing some algebra. The real key thing is you can get the derivative and you can express it in a way that's not, completely redundant. Like I said, at the very least, get here to this last step that I wrote in black, right? But the final answer, the one they'll give you in MyLabs Plus, is this one here in blue. Okay, hopefully that helps. And if you have any more questions, let me know. Thanks. Bye.